3.
Okay, this is showing the magnetic flow. So everything is staying on the inside. We're basically firing two coils at the same time, one on either side of the motor, so that it stays in balance.
Yeah, sure.
And magnets are fascinating. We've all seen this picture since we've been in fourth grade, right?
Yes.
And everybody pays attention to the power coming out or the magnetic field that is illustrated coming out of the north end and looping back into the south end. And it goes in ever increasing waves on the outside. And people say, well, that's why it's permanent, because it's constantly being recharged from the south end and it's not losing any of its strength. But what they don't pay any attention to is coming out of the middle of this, going out into space, is an awful lot of power. But it doesn't lose that power because it's always being fed from the south end. We live in a giant magnetic bubble here, okay? And it's a giant magnetic field. Now, it's constantly being recharged, but what happens is that when I combine those two fluxes and I give it a path of least resistance, it will always take the path of least resistance. So rather than going out into space, it gets pulled over and is converted into work. So what was being lost and actually what was never even counted, because when they rate this magnet, they say, well, yeah, that's gone into space, but it's being recharged, so we're just not going to count that. We're just going to count what we can use here.
Yeah.
So what is lost, they don't count. But by redirecting it, we're converting it to work, and we're getting more work out of the magnet.
So you're capturing that was lost before,
Exactly.
turning it back into work.
Exactly.
Yeah.
Which is a good thing.
Yeah.
Okay.
Absolutely.